talk about a wide range of infrastructure elements that going digital is going to become an important part. But one of the things I'd like to start my presentations with is taking a look at why do we care about buildings and energy use. And worldwide energy use of our buildings accounts for somewhere between 60 and 70% of electricity and about 30% of global energy. And buildings have been increasing. For example, in China, buildings accounted for only about 5% of energy 15 years ago, and now it's up to 15%. And so a lot of places that have not had much development are growing quite rapidly. Other places, industry is no longer playing as large a role. For example, the UK industry is only 20% of their energy use now, and buildings account for 50% of use. So they're becoming an increasing part of that, important part. One of the things I want to start with is the idea of capturing cities and capturing in different ways. I'm sorry, the video is going to be very jerky, but this is actually a 3D model of Paris created by taking a small plane and tens of thousands of pictures of the city just flying over. It's then combined with photos at ground level so that you can do that using a technology called photogrammetry. You can see sometimes it's not great photos, but the more photos you have, the better the quality. But the image-based 3D modeling, which used to be quite expensive and difficult to get, you would have to do LiDAR, you would have to do, which would be a fixed device, sit in a room for 30 minutes and take all the measurements, or you would have to have an expensive camera overhead. Now you can use drones, you can use cell phones, all sorts of devices, and they can be combined in a single model. So that federation of data is important. It's no longer requiring us just to do that. So hopefully the data will come in. This is an example of somebody using their iPhone to take pictures of just this pump. They upload it to the server, it gets processed, and in a little while they get it back and they have a 3D model which they can manipulate on their phone. So that power being able to do large to small is somewhat new. As far as modeling environmental impacts, we've begun to look. This is a model that was created of the city of Philadelphia. You can see the underlying mesh showing up there. And the Pope was coming to Philadelphia about 4 years ago. They wanted a model where they could begin to implement and look at security. So if you look up the street, you'll see barriers and all sorts of security that's been added to the model, because these 3D models, you can add them into BIM platforms or whatever you're working on, even including the signage that's going up there. One of the reasons I wanted to work with this model, the US now has 25 cities that require by law that buildings over 5,000 square meters give their utility bills, water, natural gas, electricity, fuel oil, any other utility to the city for a public database. And Philadelphia happens to be one of those. So this large database, it's part of their open data policy, and they're one of the ones that have been most aggressive about it. It's large commercial buildings, so it's not every building in Philadelphia. You'll see that as we look at the model. It has information about its size, the type of occupancy, other metadata, as well as energy use and water, and in the US, Energy Star scores. This is what the data looks like on their website. They also have a map version of it, but you can sort the data in many ways, take a look at it in various pieces, but it's not terribly interactive. So I asked one of my colleagues, we have this wonderful model of Philly, can we add our data or add their data to it and begin to look at pieces? So what we've got here is kind of from green to red, high to low energy use, and then secondarily the same in water use. So we now can begin to look at individual elements and city pieces. But I don't have to just look at it at that point. If you look on the right side, there's a series of tabs, and those tabs are the data. So I can do the same thing that they're doing on their website. I can do a sort, I can look up a specific address, I can look at the building, seeing what's going on there, and this is a sort of possibility that you have by having a 3D model, a twin of the building moving forward. I'm not going to let that run the whole time. As far as transportation, we have similar things. I'm going to just show one quick one. This is a 3D model that's been captured of an existing roadway, and they bring it into the system. They're looking at how they can make the road smoother and automate the process of repaving this particular roadway. I'll let it catch up with me. So he's now investigating, looking at the road for imperfections, which has been captured, in this case, with a LiDAR system. So he can adjust it in the model, and then that gets fed actually to the road machinery as it's doing the repaving, how much cutting it's got to do, how much repaving it's doing. Similarly, these 3D models can allow us to capture cities and begin to look at some of the decaying infrastructure without having to send people to the individual bridges and so on. So in this case, we're going to look at one of the bridges and see what's going on. Associated with this are a number of photos, so I can look at individual photos. And there we go. So you can look at the inspection results and see various elements. There you can see corrosion, concrete's exposed, seeing what's going on, so that very quickly, without having to do a lot of investigating and measurements, you can go to the site and collect the data. Similarly, stormwater system, it's possible. There are many systems. This is the one that's moving right now. Top left is Paris, handheld device. They were able to walk through the sewer system. There are no drawings, no real understanding of where the system is or how big it is. But with this handheld device, they're able to walk through, capture a 3D version of the city. Similarly, this was capturing when the road had to be opened up because there was a problem with some of the underground utilities, being able to capture the as-is conditions there and to be able to use that. The other two I'm going to just skip for time's sake. This is one of my colleagues who's been looking with augmented reality, working with trying to tie in where that subsurface infrastructure is and being able to tie it to surface-based information so that I now don't have to dig or use other things. This is documented as it's put in place and being able to use that. So kind of a powerful tool. Another part, this is Lisbon, and what we've got here is simulating a large rainfall and what's happening. The stormwater catchment is not able to deal with all the water, and it's a little difficult to see from this view. But what's happening, the blue areas are where water is backing up within the city. And they can see where the choke points are in the 3D infrastructure. This is then taking the 3D model and beginning to look at where the problem areas are going to be. If you have a 100-year flood in Lisbon, you're going to have some problems in some of the major squares there. Similarly, this is a model of, when it comes in, sorry, Paris again, and we're looking at what happens with if the river is flooding and showing where the low points are, just based on the terrain and what the issues are going to be. It also shows as the water recedes, where's the water going to start flowing back into the river, where the choke point is going to be there. Another interesting thing a friend of mine's been working on is combining thermography, using thermography to take photos of buildings to try to begin to identify components of the buildings and also problem areas, and use that within photogrammetry. And what he's done is with a drone, basically taken a model. This is what photogrammetry looks like. You can see where each picture, the image is pointing, and you can see the beginnings of the point cloud that's resolving here. So what he's done is created a 3D model from that, just like the other ones. Waiting for it. So it allows you to begin to identify elements that are that have some issues with insulation, but also windows and other parts of the building that would be harder to get if you're just trying to collect. It would take a lot more information. He's now working on automatically identifying that, and at the same point with non-invasive instrumentation on the drones, being able to collect so that he could get with radio waves what the components of the walls are made of. So now a quick way to be able to get some of the information. Another area that's been interesting recently is agent-based simulation. If you're working in building simulation, people are primarily just a schedule. They're not actually simulated in what they're. This kind of turns that on their head, where each person is a simulation that you can, based on population type, culture, various things, you can begin to do the simulation of what's happening. So here's an example of working with a subway station, looking at choke points within the subway itself, and you see at the top or at the bottom where we've got some real problems with that. So within the BIM model, you can do this, be able to go in and add new elements and re-simulate without having to go look at that in other ways. So it's showing adding another, and now the choke points have disappeared for that same amount of people coming through, which is a much better solution. Another thing that's recently become available, this is a map of traffic over time in the US over a 24-hour period. And the way this is generated, this is based on cell phones, collecting information not individualized, but the fact that there is a cell phone signal on the road at any one time. They can begin to collect, see where the traffic volume is. And you can see the East Coast is much worse all day long. Similarly, this is Singapore, and being able to look at what the traffic information is like now, and then they are putting in a large new development. How much is that extra traffic going to affect the problems, and being able to look at where they should start to focus on dealing with some of the issues. The last, excuse me, last thing I want to show is kind of a case study of city of Helsinki. Helsinki has been creating these 3D models of their city for about 7 years. Sorry, it will come in. The most recent model, and this is not it, I'll show you that in a minute, is down to a 10-centimeter resolution. And they've got 26 square kilometers of the city modeled at this point. And they've been working with it to try to see what aspects of this digital twin of the city they could use, and I'll talk a little bit more about that. But this is the model that they finished just this past year. It is a mesh, just like the other one, but it does have finer resolution. One of the things they've been adding is looking at machine learning, deep learning algorithms to begin to automatically identify what's a roof, what are trees, what are other elements of that. And that's kind of an important part of what's going on. Now, the city has already begun to look at how they go about, what is it they could do with this data and the uses. And you see the use cases here along the left, smart city, something very interesting that they're already beginning to pursue. You see the green dots there, but you see a wave kind of all sorts of other things that they haven't really begun to do. And one of the things that we've heard a lot of hype about 5G, the next cell phone capability, is that it will enable, because of its low latency, is going to be able to enable the Internet of Things in a way we've not been able to. And transportation is one of the big issues there. But they've got things like building permissions, building design, city planning, tourism, city events, network and lighting, all sorts of things going on there. So they have put a plan out about what they can do. And the city's been very open. These data models and everything that we're getting are from the city's website. You can go and capture any of this information. So I will do a quick summary. These 3D models or digital twins can really make it easier to understand our buildings, understand in context, no longer buildings as a separate entity, but how do they fit in with the context of that infrastructure that they're going to become part of. This is not a single model, it's not a single piece of software. They can be from many different sources, combinations. You can even include detailed BIM models in with the point clouds to be able to deal with it. And there's a lot of different capabilities across there. Many models and data sets available. I think what's probably most important is a holistic way of beginning to look at some of these risks of long-term flooding, resilience, sustainability issue at a community or city scale, and allows you to do it across many disciplines. So it won't just be building designers, it'll also be looking at transportation, looking at other infrastructure related there. So, and again, 5G beginning to deploy, it's going to give us that smart cities aspect. But it's going to be an interesting thing. One of the things I just learned in the last few weeks is the 5G antennas do not have the range that we're used to with 3G and 4G. So it's going to require many more small antennas. The closest 4G antenna at my home is about 1 kilometer away. It's no problem, signal's great. But they've just put in, just down the street, a 5G antenna because it's going to take that to be able to get that low latency there. So also, as we have these data sets begin to come together, we're going to be able to measure everything and manage it in ways. But 5G does provide kind of another issue, which is really data security and how do you bring this forward. So with that, I'll say thank you and take questions.